know what I don't like is, I get it that quick, but then you guys gonna copy paste and not thinking, what's the logic behind it, okay? You guys all have access to this book, right? Yeah. Okay, the problem we're gonna solve is what? Let me see. 1. Okay, so 11 is the first one, right? And 11, I just did it really quick, and I think 11, my approach is probably faster. Okay, and I'm going to copy this part. Oh, I'll copy this table, but I don't want to use that. Okay, so let me fake some new number here. Okay. Let me fake some new number here. Make this one. That's hard. Okay, I'm lazy. I'm gonna use my random number approach faster that way. Okay. Ignore the first table, okay? This is what I did to get things done quick. Control C, paste special values. Okay, and let me just this has got nothing to do with what you do. Okay? And here I'm faking up the table first. Everybody divided by this guy. And I will lock the number. To me, this has got pretty much the same thing what I would do in experimental design. But here, step 1. You have a 3x3 table, agree? And a 3x3 table, how do you know is a probability table is basically doing this. Hey, sum them up together. If they're equal to 1, that's a table, agree? And of course, once you have that, you can have everybody sum up. I can sum row first or sum column first. That's the table, agree? Next, if I want to say that, hey, I only care about given the the B, what will happen to A? Given the B, what happened to A? So now I'm going to create a table. A problem here is given a BJ, what will happen to A1? And given a BJ, what happened to B2? Given a BJ, what happened to A3? Okay, so how you create that? All you need to do is this. Everybody, okay, I should copy here. Everybody here equal to whatever that probability I have, given I'm in this, given I'm in this group. What did I do? Equal to this guy divided by this guy. And I'm going to lock the location. Okay, so you will do the same thing. And, well, I can do this all the way here. If I divide it by myself, I should equal to some things. Ignore this. This equal to this. Okay, we're good. Just Control C, Control V. This is kind of for me to double check. So now here are 9 number, right? What are those 9 number? Given B1, what is my A1? Given my B2, what's my A2? Given my B3, what's my A3? You guys totally visualize it, right? Right? And pick up, this is what I did the same way. Given my A1, given my A2. Okay? Now, I can play this game the other way. This time I do. Show hands. All get it? Okay. Now I'm going to do it the other way. And this time I'll do this. Given my AI, what will happen to A1? Well, AI, what will happen to my B1, B2, B3? And so I'll do this all the way here to my B2. Okay, so everybody equal to what? Whatever I have divided whatever you give me at A level. So this time, we lock the column. And all you need to do is Control C, Control V. And voila, you're done. It's A1, A2, A. Okay, problem 1 is like that. I can be 4 by 4, can be 10 by 10, who cares? Okay? And of of course, you can write it like you can write it one by one. That's a little bit busy in my view, but this and this, same thing. Okay? Next problem. I don't know what's the next problem. Oh, next problem is easy. Next problem is, I say yes, I say no. So this table is not a 2 by 2 table. This table is really, if this is a 2 by 2 table, the sum of, usually this is what I did if I'm writing code. If this is a 2 by 2 table, the sum of those 4 guys, the sum of these 4 guys, or whatever in the contingency table should be equal to 1. Okay? And that's usually how I figure it out is sum. That's all. Y equal to 0.
All those are fixed.
Huh? Those are what?
All those are in the form of text.
Oh, they are text? Okay. Oh. Okay. Let me do this then. Equal to this times 1. Control C, paste special value. Okay. So usually what I do is I check the sum, and then I know, oh, this is a case by case. And if this is a case by case, everything's easy. Well, because the problem they said is that, hey, I want to know this one. Given I say yes, here is the problem for the second one is I say yes, and the T is test is yes, and A is yes. But T is yes could be what? T is yes given that A is yes, and given A is no. Here, let me blow up a little bit. Okay, the yes have the 2 situations. A is yes, given A is yes, test is yes. So giving back here is the given the situation 2 and given the situation A. So now I'm saying, oh, given I say yes, and then also yes here, so I'm using yes and then yes. And then this guy is yes and then yes. So the 2 different kind of yes, yes, yeah, but, no, but yes, or yes and yes. The sum together is this much. And all I care about is this is how much among all the cases here. And that's equal to that one. You guys see that? Right? I have 2 different ways to say yes, but the outcome. So I'm just trying to figure out, hey, what's the proportion of this guy over this guy? And then all I did is I copied, paste the whole things and said, oh, but now the proportion is now 20 to 80. Change to this. So what I did is copy this guy and paste it again. I got the number. Okay, that's problem 2. Okay? Hey, I know some of you just, you don't care about anything, you just care about your grade. But let me put it this way, okay? For whatever the cloud computing, artificial intelligence, machine learning, that's the future. I'm gonna retire in a few years, I don't care. But you guys are gonna face this kind of music for the rest of your life, okay? And so, don't just copy paste the number. Think it through. Yeah.
I know, like, the textbook had another way that it was kind of solving a question like this, and it was using, like, the lambda test.
I did not do that.
Okay,
And
I was just wondering if you could, like, maybe after we go over this, can you
Can
explain that?
can I capture that? Because
Like later,
huh?
like another.
In another time. Because
Yeah.
that is beyond the scope. What I'm saying is, yeah, I can give lip service, but then that's a different route. Just like, I'll be honest with you, technically, I should give you a toy to play with. Some Bayesian network toys. If you guys look, there are probably 10, 20 different Bayesian network toys software out there you can download, and R got a pretty decent package, okay? And so we can do that. I can talk about this a little bit later. Why the books talk about it that way, okay? I actually didn't read a book, but I think I know what you're talking about.
Thank you.
Yeah,
I
but-
just- that was an approach that I wasn't sure if it was, like, supposed to be applied here, and it wasn't, obviously, but.
Yeah, but you guys see how I did it, right? And the so-called software, a lot of times, they're doing exactly the same things. This, I like Excel because what you see is what you get. And once you visualize it, the rest is not a big deal. This is all related to one problem. You remember last time who asked me these separations? Yeah, he did, right? And this is all related to this, right? Here, ground is wet. Can we use this probability sprinkler to explain it? Can use the rain to explain it? But if I ask a really smart questions, hey, is it cloudy today or not cloudy today? Then suddenly that extra frame of reference separate, once you pour that out, problem becomes easy. So this is all related to, okay, if I have 20, 30 different questions I can ask, which one I put it on the top will make the explanation really, really quick. Remember last time I talked about the hot and sour soup things? The hot and sour soup things is really trying to tell you that ideal case will be what? If I frame the problem right, once I frame the problem, whatever inside the problem becomes independent, is that will be, the ideal situations. And you know, if you frame it wrong, before is not independent, after is not independent, then who cares? But what the computation really trying to tell you is that how to be smart, ask the right questions. Here, say you have a car problem, you go talk to the car mechanics. The smart car mechanics ask you a few questions. Did you hear the chattering sounds below 55 or after beyond 55? It's on freeway or on local. Okay, you will ask you a few questions, and what the question trying to do, frame the probability statement and make it really quick. That's all the purpose here. The smart doctor, right? You got in and said, "What did you eat last night?" One or two questions reduce the space of computation really quick. That's all. Hey, do you think the Homeland Security stereotype people? Yes, no. But how to frame the problem in a proper way? One or two questions. You get the answer. So obviously, here you can tell. Does the police have bias or not bias? And you can easily solve that problem. Okay, the next problem is the one a lot of people have questioned with us, right? Yeah? And before I do anything, okay, I just want to show you this. Okay, is how many factor here? 8, right? So how many way I can express this? I can express it this way, right? Put it this way. Can I express the problem this way? I'm teaching experimental design now. I have a bunch of A1. I have a bunch of A2. I have a bunch of B1. Oh. Darn. Okay, see if I can get rid of it. And I have a bunch of B2. Okay, and then I have a bunch of C1 and C2. Okay, can you put those A number according to this arrangement? Yeah? So I can put this A number, this arrangement, right? But can I do it this way? Let me do it this way. Okay, given, and then all I need to do is sort. By column I. And then at another level by column J. Okay, can I start from a bunch of B1 and then A1 and then, see here? Before was A1, 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 A2, 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 right? But can I sort it this way? Talk about B first and then A and C after. Can I do it this way? Let C go first and then sort by column H and then by column I. Does it matter which one first, which one second? It doesn't really matter in experimental design, right? So, but in the language logics, in my hot and sour soup is what? I like hot soup, I like sour soup, do I like, Indian food? Given I like Indian food. So you basically start saying, you frame the problem, I was first given this and talk about that, given that and talk about this. And given means what? Whatever given is on the top, right? You guys follow my logic here? If I do it this way, it's almost like doing this, right? Given C, and then I'll talk about B. Okay? And then, of course, then I need to know PC. Okay? And then, of course, I can have this. And then I can say, given B, I'll copy paste here. So this one technically will give me join BC, right? And then what's this? And then I can say that join BC, and I can say, okay, given BC, can I talk about A? Can I do this? This is the chain of, hey, given this, given that, level by level, added up. And is anybody can tell me the sequence must be this way? Or can I have a different way? You can have it any way you like, right? Right? I only have three things. Well, what I'm saying is that, okay, can I ask you a question for dinner? Would you like to have salad? Okay, given you want to have a salad, would you like to have a salad dressing? Given you like to have a salad dressing, would you like the salad dressing inside the salad or on a cup? Can I do it that way? Right? But can I, that's the logical sequence of asking something, right? But can I just do it to annoy you? Would you like your salad dressing in a cup or inside a salad? And then ask you all the question in the reverse process. Logically, I can do that, right? But if I logically do that, it's annoying. That's not the way how you think. So you basically try to figure out that I can express probability in so many different ways. But which way is the right way to elaborate the intelligence? Okay? So that's what this exercise is all about. So how you do it? Okay? The first thing I did is this way, okay? Usually what's the first thing I do? I sum them up. If I sum them up, they're all equal to 1. I know what? I know this is a contingency table. Now, here comes the second fun part. Look at the contingency table here. I put A on the top, A on the side, BC on the top. Okay? How many people think that this is the only way to express that table? Just like I can have a different combination in one pile with different sequence. Can I do it here the same way? What I'm saying is, can I do it this way? Okay, just ignore the number inside. Okay? But can I have B1, B2 here, and A1, A2 on the top? Yeah? Okay. In experimental design or in data structure, sometimes people just say that factorial design, the crossing design, can turn into a tree design. And when you turn into a tree design, it's basically said that this is a tree design. C go first, and then B go as the branch, and then A as the twig. And I can have A go first, B go second, and just basically you have different way to do the computation. Okay? And which way is the right way? Later on, I will explain to you. Actually, it's based on KO divergence. Okay, let me give you a little lip service here to help you understand this. Okay, that ground is wet, could be due to rain, due to sprinkler, but cloudy. If I have cloudy, not cloudy, rain, not rain, I have 4 variables, right? So totally I have 16 different combinations. But obviously cloudy is the frame I'm using to frame the whole things. So at the end, people basically said, 1, what is the right causal structure to answer something? Which one should be on the top? Which one should be at the bottom? The bottom line is which one will reflect the reality the best. So the probability if the histogram looked one way and say, oh, this case here. If I have everything's here, okay, say 8 different conditions, and based on this A condition, can I have a set of observation and say, what's the probability, what's the probability, what's the probability? So I can do this very quickly. Fake a table here. Okay. Control C. Paste special value. Okay. And so of this. Okay, and then everybody divided by this guy. Okay. And I'm gonna fake the table here. Okay. Paste special equal to 1. Suppose that I have A conditions, and then here's the observation. So this is the truth. You know, I have A conditions, ran or non-ran, all that stuff. Okay, here I'm just saying that there are some, A variable can, A 2 by 2 by 2, I can have A different condition. I say, how many times in this condition, how many times in that conditions? Can I easily do that? And then, of course, I can have, you know, all kinds of different sequence, or let's just say that here is observation. Okay, here's the observation. Okay, and here we're just saying that some Bayesian network tricks or dirty tricks. Okay, and I have dirty trick 1, and I can have, let me insert 1. Let's just say that I have 4 different dirty tricks to model this. I think it's too many, but let's just say that I have trick 1, trick 2, trick 3, and trick 4 to model this. Okay? And how to model it, that's where those yada yada stuff coming in. But let me just say trick 1, okay? I'm going to end up with 0.999 and 0.001, okay? And the rest will be 0. Okay, just by one look, do you think model 1 a good model or bad model? Saying that, oh, most of the opportunity is here, and a little bit here, the rest is nada. Do you think that's a good model or bad model? Just by compare that with the observation. Good model or bad model? Bad, right? But if I have another one, just say that this is equal to 1/8, equal opportunity. Do you think that's a good model or bad model? Everything is 1/8, 1/8, 1/8. Think about it. Okay, here's my observation. So compare with my observation. Compare with my observation. This model is not too bad, right? It looks close. Or I have another model. Here is 0.4, 0.3, 0.2, 0.1. Well, I can make up some number. But sooner or later, you know that some model is very close to a reality. Some model is not close to the reality. And the game here is whatever you do, you just want to make sure your organization is as close to the reality as possible. How many, show hand, how many people understand that we'll model this, but sooner or later? Okay, question number 1. There are many different ways you can model a set of data. Agree or disagree? Model, number 2, some model closer to the reality, some model sucks, not too close to the reality. So we need to compare them. Okay? Now, Suppose I come up with two models are almost equally good. Okay? But one model use a lot of variables, but one model use few variables to come up with the outcome. Which model is a better model? The one with less explanation needed. This is like experimental design. You can talk about everything under the sun, put them in an experiment. But if you can come up with a few things, but come up the few things predict the whole things, that's a good model, right? You go to the hospital. Do you like to have a doctor blood test, ultrasound, CAT scan, and then let you struggle for 2 days, test, and at the end the doctor says that, well, we don't know what happened to you. It depends. That's a horrible doctor, right? What would be a good doctor? Coming in, ask a few questions, boom, reach the answer. So all we're trying to do right now is trying to say how to abuse the probability. Okay? Just like, experimental design, how to abuse the observation. The second thing is that, now, if you agree with me, there are many different ways to model this. Right now, I'm just saying that at least you can see that there are many ways to tabulate these things. Agree? Before, I'm showing you that I have, arranged them in different sequence. I can arrange the 8 observations this way. But here, I'm saying that I can tabulate them any way I like. Okay? Now, the next things, let's look at the problem, what it asks. Okay? The questions on this one is, are A and C independent given B? Okay? What does that mean? Means, okay, are A and C independent given B? That's the question, right? Can anybody think this question is very, very similar to the D separation hot and sour soup questions? I like hot soup. I like hot stuff. I like sour stuff. But given I like Indian food, the hot and sour become independent. A could be hot, C could be sour. Given I like Indian food B, then the hot and sour become independent. Follow me? So you can express this many different ways. One way you can express this is that, okay, I like A, and I like A, I like C, okay? But if given B, okay? Then the join probability, I don't know how to do join here, but let's just say N, C, given B will be the same. That is the statement, right? Or I can write it in the opposite way, but here. Look at it. Given B, I like A and C is equal to, well, let me write it the opposite way. How many of you can see this? No, let me do it this way. This is the same questions we asked last time. If you like hot and sour, you like Indian food, then hot, given Indian hot, given Indian sour will become independent. Can you guys see that mathematical statement is the same thing what I did last time? Show hands. How many of you see it? Okay, so if you see it, then you know that language statement and probability statement were doing the same things. Okay, and of course, mathematically, how they did it is this way. Okay, first they prove that. Okay, this time since this sum equal to 1, so I will say that okay, let me sum the bottom. So when I sum the bottom, this 4 value are what? Given B, then C, this is here, this 0.02 is what? BC regardless of A, right? And this is BC regardless of A. This is BC regardless of A. BC regardless of A. This is B1, C1, B1, C2. Everybody sees this 4 beige color? Where they're coming from, right? And then what I did is this. Okay, since I know this is the BC, and now I said that given I know BC, let me check A. Given BC, I check A. Given BC, I check A. Given BC, I check A. So this A number is what? Is equal to, I'm doing this. Okay? B1, C1, B2, B1, C2, this is 4. Can everybody see that B1, C1, this 4 number equal to this 4 number? Agree? Now, I'm start playing tricks is that, okay, everybody now divided by given that B1, C1, okay? So I get 310, 310, 37, yada yada. I done. Okay? Now, this is doing it this way. But now I did it the opposite way. This time I said that, okay, if I merge the BC here, I add this 2 column, added this 2 column together. That means what? I only care about A under here. If I use a different color. Let me see if I can use a, okay. Say I use the purple color here. Adding those 2 numbers together, what does that mean? Adding those 2 numbers together is regardless of C, this is BA1 combination. Agree? Agree? And so BA1, no matter your C1 or C2, it's the same thing. And this is B2A1. So this A number is condensed by this 4 number. Okay, you see that? Now, if I do that, okay, I'm still doing the comparison is that, okay, now I have the BA1, but this time I want to divide it by under the sum here, under the BC1 or under the BC2, and you will see exactly the same number. So mathematically, I'm trying to prove these things. Wrong table. Is I'm basically said that, hey, given I know BC, okay, given that, let me think which way to explain this will be faster. Okay, look at that statement there. If given BC, I know A is the same as given B, I know A, that means that once I know B and I know A, C is irrelevant. Agree? So C got nothing to do with the computation here. So if you do that, I'm trying to go back to, yeah. Everybody agree with me that this is a hot and sour soup statement, right? We already did it before. Now, if I do it this way, and let me add one more. Given BC, no, this time it's given okay. People for 13, you have 3 ways you can prove this. One is doing this one. And the other 2 are doing the 2, I'm only showing you one way. These 3 things, they're all talking about the same hot and sour soup statement. The first one is obvious, or at least you guys remember, I explained it to you last time. Given I know B, then A and C become multiplication, become independent. But that statement can be expressed in 2 different ways, okay? One is, hey, given B, what is A? If you want to know, given B, what is A, you don't even bother to know what is C. So here, original statement is that given BC, what is A? But given BC, what is A, is equivalent to given B, what is A. So, if this statement is true, do you really need to ask C? You don't, right? Means what? C is independent from the situation. Agree? Agree? Okay. I need to know him. Does he like French food? Okay? And of course, technically speaking, I need to ask your wife, does she like French food? If you both like French food, then I know you like French food. But if, okay, you too, the statement, once I ask you, and I pretty much can decide if the French food is good or not, means what? Your wife's opinion is irrelevant, is independent. Right? Or vice versa. So here is, can you guys see, this one is trying to say that, oh, given B, to understand A, C is irrelevant. Given B to understand C, A is irrelevant, is independent. Can you see that? So you can prove your problem 13 in 3 different ways. The hot and sour soup way, this way, or this way. And the statement basically doing this twice. Okay? One is to prove that I can calculate probabilities this way, or I sum them up and calculate probability. Look at this 2. Are exactly the same. When they are exactly the same, here I'm proving this statement. If I know BC, I know A, or even I know B, I know A, I'm going to end up with the same things. And if that happens, means what? Do I really need to talk about C in that computation? No need. Once I know B, I know C. I don't need to get A involved. And this one is the same thing. Given, I got it opposite. Given I know B, I know A, I don't need to get C involved. This is given B, I know C, I don't need to get A involved. You guys follow me? Let me see if I can change the color here a little bit. Basically saying that this guy, let me change the color here. If I can. C is not important. Here is the other one saying A is not important if you know B. Okay? So problem 13, if you really want to do it right, you should do it 3 different ways. Okay? Do I confuse you, or you think you can struggle through 13 now?
So I just have a question on how to do it. Like, I understand what you're explaining, like the importance of like finding probably a given B, like the purpose of not using C. I think what I'm having a hard time is like visualizing how to do it using the tables.
Okay.
So like I was following with you when you were doing.
Okay. Because I have one more to go. So let me see if I can get her here. You can build a table this way. So this one I'm building it to. I'm not saying this is the best way to visualize it, but this is the way I did it. Here, this one I'm trying to single out A and say A is not important. Okay, so I'm putting A on the side. So given B, so this one is trying to do this one. I'm sorry. Given I'm trying to say C is not important, and why C is not important? Because okay, first let me pretend C is important. So I let C here. I let C here. Did I calculate every C contribution in BC, 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 BC? See that? And given BC, 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 and then I start saying that, okay, under the level of A1, under the level of A2, I get this A number. So the first 2, I'm calculating this stuff. Okay, I let BC, but I let A involve. Oh, I'm sorry.
So
Here.
The table that you have right there, the probability of A given B.
Yeah, well, given AB, here. Let me be careful here. I don't want to confuse myself. Okay. We know we have the B, given B, and then I'm saying I need to do here. Would you agree with me? There are 3 different ways to prove it, and I'm showing you one way. The way is, this is a way to say C is irrelevant, right? This statement is to say C is irrelevant, agree? So I need to do that table twice. First time I do it this way. Given BC, I get A. And then I do it, given B, I know I check A. But if I can show that given B, I know A, and given BC, I know A, I'm going to end up with the same number. Then I know that knowing or not knowing A is not important. Knowing or not knowing C is not important. Agree? So far, so good? No. So we're doing it here. So we bury the guy here. Here is the stuff I pretend. I made a mistake here. Here should be C1. Here should be C1. Here it should be C1. Okay? And so first, I'm calculating this cell by cell. Means what? There are BC1 level, BC2 level, B1C1, B1C1, B1C2, B1, B2C1, B2C2. So I have here I have 4 different stuff. So that's my 4 different stuff. But all 4 different stuff, I need to say, hey, what happened to A? So I need to have A involved here, here, here. So everybody is divided by, what's that? So far so good? Now I'm saying that, what if I lump them together? I don't care C. So C1 or C2, I don't care. So C1, C2 lump. And so see here, C1, C2, same thing. C1, C2, same thing. C1, C2, same thing. C1, C2, same thing. But once I use C1, C2, the same thing, I recalculate the conditional probability. Hey, I'm gonna end up the same answer. Like I split them into 8. So this 2 table, the table here and table here, saying that no or not split or not splitting C1, C2, you're going to get the same answer. That is the way to say C is irrelevant. And you can do the same thing for, so that's C is irrelevant. So can I do the same thing for A is irrelevant? Can I just do the hot and sour soup approach and do that, okay? And for grad student, I would say this, okay? I'm not saying I'm good, okay? I'm just saying there are grad students ask me to do capstone project with me, and I would say if you're not doing taking DOE with me, you're not taking reliability with me, you're not taking Bayesian with me, and you just said, oh, I like my engineering management, and suddenly you want to come and say, I'm going to do data mining or machine learning with you, the likelihood I'll take you is very small, because I feel like, you know, my way of thinking and your way of thinking never check. But if you can solve the problem, in many different approaches, saying that, oh, I fully visualize this whole things, then I know that, you know, you can do it, then we probably can go for something good. You follow me? Yeah, but back to the labor-intensive part. You know what I mean? You with me? This is with C, this is without known C, so you have the C1, C2, same thing, C1, C2, same thing. You're going to end up with the same answer. Agree? But you can play the shuffling game, move the seat up here, and well, you can move the A up here and C down here and play this. Here, I know what I really want to do is saying this. Okay, can I have A1, A2 here, and C1 and C2, C1 and C2 here. Can you create a new table by changing the sequence of this A number and create a new table this way? Can you do that? And what's the purpose? Is to say frame of reference, right? How I frame the problem, but I'm going to get the same Bayesian probability. That's what I'm talking about, your Bayesian tricks. Okay? Yep.
So when we do the way you did it, right, in the 2 tables that we calculated
irrelevant or A is irrelevant. But if you can do that, you're basically saying that my conditional probability, if I frame it based on B, no or no, to figure out A or figure out C, I don't need the other guy. Make sense? Yeah. I think the other days you guys see that if you frame the problem right, knowing I like something, then the other things inside become independent. It's easy to visualize, right? So it's all about that kind of, can you ask the right questions? Okay? Human factor actually a lot of time check on this, but when you start talking about machine learning or data mining, basically you don't care. Let the computer try every possibility. And whichever the frame, you're going to end up with your true observation, you have a good model. Okay, before I move to the next one, can you guys do the work, but also understand this is related to de-separation, relate to the language versus the probability statement? Okay. Yeah, if you really learn this stuff, the job market is there. Okay. I don't care. You're a computer science. You're whatever engineering. This software engineering, whatever you call it. The bottom line is, we're using cell phone. We're using QR code and barcode. Everybody got tons of data, and everybody try to figure out based on the data what makes sense. Okay. There's one more problem, right? Oh, there are two more problems. The other two problems, I'm going to just show you quickly, okay? The problem 16, or here, all you need to do is that have a probability, you have your PDF, and then you do an integral from 0 to 1. And if you do an integral of your PDF from 0 to 1, it should equal to what? Total area under the PDF should equal to what, right? And if the total area equal to 1, half A equal to 1, A must be 2. And once you know that, can you find the integral of mean times the PDF, or mean minus x, or x minus mean, doesn't matter. Y doesn't matter because you square it, right? You square it, so mean minus x or x minus mean, that should give you the variance, okay? And then, so this one just, I'll say stat review. And the last one, okay, is basically saying that, okay, I'm going to do the integral, but the density function is from 0 to pi. And then you solve this simultaneously, okay? I don't like this problem, but just do it. But what I'm trying to tell you is why sine cosine is involved in this business, okay? So if you understand why sine cosine is involved in this business, you probably can learn more. Here. If, okay, I have a random number from 0 to 2, I'll probably do it this way. I have a random number, okay, and from 0 to 2 pi. And let me just do it, maybe 2,000. Okay. And another one. Control C, Control V. Okay, so let me lock the value. Control C, pay special value. Okay, if I do that, here is a bunch of random number from 0 to 2 pi. And can I say this is a cosine of this guy. And this is sine of this guy. Okay? So one is sine of the random number, one is cosine of the random number. Oops. Okay? If you plot a sine and cosine, what are you going to get? Except the first one. Insert a plot. You're going to get a perfect circle, right? Oh, I need to r cosine theta, r sine theta. Let me just use here. Let me use 5 terms. You'll get a perfect circle, right? But if you calculate a correlation coefficient between the x and y, C-O-R-R-E-L. Okay? It's going to be very, very small. But in reality, you know this two number, both are from the same angular sine cosine value. Agree? So should they be they should be very, very high, right? Can anybody explain to me why sine cosine is a sinusoidal movement? That, you guys follow me? Both are from the same, well, if I do it this way. Let me just use this guy plus 0.1. Here, let me just use the value. You guys see a perfect circle, right? It's a sinusoidal movement. So if one is x, sine is cosine, just physics. Why the correlation is so small? Can anybody explain to me? Are these two number, here, one is r cosine theta, one is r sine theta. Are they related or not related? Here, is x and y related or not related? People, x and y related or not related? Related, but if they're related, they should have the correlation coefficient 0.99999. How come I have a correlation so tiny? Because correlation is for linear correlation. It's explaining a lot of things in linear way. Here was just saying that sometimes x and y increase and you're going to end up with something different. That's the purpose that he's supposed to talk about in Bayesian networks. Bayesian network can explain a lot of things nonlinear, not based on if you guys learn experimental design or DOE, they all try to do the so-called linear relationship using sum of square. Bayesian network is always doing count, so I always fake the number or doing the probability based on the relevance. So the key here you should know is Bayesian network got nothing to do with distance. Bayesian network has got everything to do with count. You know, I have a high chance getting this or low chance getting this. I have a high chance wearing a raincoat when it's raining. I would have a low chance wearing a raincoat if the sky is clear. It's all based on chance, based on probability. You learn your regression or your experimental design, generally, general linear regression is based on distance. Don't confuse the two things into one. If you don't separate the two, and in a job interview you start talking about associations, you should be able to talk about the difference between the two. Other than that, do you feel comfortable to solve your homework problem now? I'm not confusing you, right? Okay, last piece. You guys watch the videotape? Any question you want to contribute? Okay, let me think about it. Maybe I'll fake a couple homework problems. I know Dr. Guanglin only gave you till homework 6. I might fake a couple problems based on the videotape and do something else with it. But first thing first, make sure you can solve the problem. Okay? Adios.